Okay, so in the previous lesson, we derived the formula in finding the nth term of a geometric sequence. This formula allows you to accurately identify the nth term of any geometric sequence. We shall now proceed on discussing how to find the sum of the terms of a geometric sequence. Consider the geometric sequence 3, 6, 12, and 24. If I let you find the sum of the first 5 terms of a geometric sequence, maybe you'll simply generate the 5 terms, then add them. For example, 3 plus 6 plus 12 plus 24 plus 48 is equals to 93. Pag ang out mong pangutanon nga, kuhaon ninyo ang sum of the first 5 term of geometric sequence. So, ingong anion dyan ninyo, di ba? I-add lang ninyo siya, tapos i-generate ninyo ang ika-5th term. What if I asked you, what is the sum of the first 10th term of the geometric sequence, or the 15th term and the first 20th term? Would you still be able to use this kind of technique in solving this one? So, di ba, mas lisod siya. Or mas taas pa imuhang buhaton bago ka makakam up sa sum of the geometric sequence. So, karon, I will discuss to you on how to find the sum of the term of the finite and infinite geometric sequence without going through the process of adding the terms one by one. So, without using this one. So, naatay technique karon nga buhaton. So, let us have our first example. Find the sum of the first 5 terms of the following geometric sequences. So, let's start with number 1. So, we have here a geometric sequence which is 7, 14, 28, and so on. Basically, you will definitely first identify the first common ratio of the sequence to generate the next term of the sequence. For this item, the common ratio is R is equals to A sub 2 over A sub 1. So, A sub 2 nato is 14 for the second term. Then the first term is 7. So, 14 divided by 7 is equals to 2. Therefore, our common ratio is equals to 2. Next, the first 5 term of the sequence are karon kay na naman tayo common ratio, so pwede na natong makuha ang first 5 term. So therefore, the next term will be 7, 14, 28. So 28 times 2. Diba, para ma-generate nato ang next term pag geometric sequence is i-multiply lang nato ang kaning nga term, na una nga term, i-multiply nimo sa common ratio para makuha nato ang next term. So, 28 times 2 is equals to 56. So, mao na itong ika-4th term. The next, kanina pong 56, multiply na po taan ng 2. 56 times 2 is equals to 112. So, mao na ni siya ang atong first 5 term. We have 7, 14, 28, 56, and 112. And now, kay tungod, ang question is, find the sum of the first 5 term man, mao may nakaingon. So, ato ni silang i-add tanan. So, using the formula, using katong ang technique ganiha, which is, mo na to siya 7 plus 14 plus 28 plus 56 plus 112. Therefore, ang equal niya is 217. Now, the sum of the first 5 term obtained is 217. You were able to find the sum by generating all the terms and then adding them. But how about the sum of the first 20 term? Are you still going to generate all the term and using this one to add or to get the sum of it. So, medyo time consuming siya kung kanya itong gamiton kaya mag-generate pa ta sa next term. The 20 term ang atong pangitaon. So, medyo taas-taas ng atong pag-solve. So, kani siya, class, kani siya is atong ginatawag nga geometric series. So, pag mo ingon tag geometric series, it refers to the sum of the terms of a geometric sequence. So, inig magkuha tag 20 term, 30 term, and so on, yung mga big term na atong pangitaon. So, mag-need na ta og formula ay for us nga easier na tong ma-solve o makuha ang kato nga mga terms. So, this one is the formula in finding the sum of the first n term of a finite geometric series. So, ang atong formula nga gamiton is S sub n is equals to A sub 1 times the quantity of 1 minus R exponent of n all over 1 minus R. So, mauni siya ang formula nga need ninyong tandaan para makuha natin ang sum of the first term of a geometric sequence. So, now we have here our formula. So, S sub n is equals to A sub 1 times the quantity of 1 minus R exponent of n all over 1 minus R, where S sub n is the sum of the first n term of a geometric sequence. Then, ang ating A sub 1 is the first term, and number of terms are common ratio. So, balikan naman natin ang ating example, number 1, which is find the sum of the first 5 term of the geometric series, which is 7, 14, 28, and so on. So, using the formula that we have here, S sub n is equals to A sub 1 times the quantity of 1 minus R exponent of n all over 1 minus R. So, yan na yung gagamitin natin dito sa pag-solve. Now, let us try to solve this problem. So, we have the given A sub 1 is equals to ang ating first term, 7. We also have our n, first 5 term. So, n is equals to 5. Then, kanina, di ba, nag-solve tayo ng common ratio. So, ang r natin is equals to 2. If you still remember. Because we have second term divided by first term. So, 14 divided by 7 is equals to 2. Kaya, 2 ang ating r. Now, let's substitute this given in our formula. So, we have S sub n is equals to A sub 1 times 1 minus R exponent of n 1 minus R. So, substitute na natin. So, ang ipangita na to is first 5 terms. So, ang n natin will be 5. So, S sub 5 na siya. It's equals to ating A sub 1 is equals to 7. Kung unsay naa diri mo atong ipang butang diri sa ato ang formula. Substitution lang, di ba? So, 7 times the quantity of 1 minus R, which is 2. And exponent n, ang ating n is 5. So, exponent 5. All over 1 minus R, ang R na to is 2. So, let's solve. Using the PEMDAS method, so parentheses, exponent, and now we have 1 So 2 exponent of 5, we have, pila man? We have 32. One minus 2 is equals to negative 1. So S sub 5 is equals to 1 minus 32, 7 times 31. Negative 1 over. S sub 5 is equals to 7 times 31. Pila man? Ay, delete ni. 31. Negative 31. I forgot the negative sign. So, 7 times negative 31 is equals to 217 all over, negative 217 all over negative 1. So, therefore, S sub 5 is equals to negative 217 divided by 1 is equals to positive 217. Subtract na. So, therefore, the sum of the first 5 term of our geometric series is 217. So, masayo ni siya kesa sa pangitaon sa nato ang iyang mga term, then i-add na to. Okay, what if dili na first 5 term, mas taas pang iyang ipangita. So, using this formula, it will make our solution, or it will help us to answer this problem nga masayon o mas mubo ang solution nato nga magamit. Now, let's try another example. So, example number 2. Find the sum of the first 5 terms of the geometric series 3, 12, and 48. So, using the same formula, this one. So, let's try this. S sub n is equals to a sub 1 times 1 minus r exponent of n over 1 minus r. So, substitute the given first 5 term pa rin ang hinahanap natin. So, ang n natin will be 5. So, S sub 5 is equals to a sub 1 is 3 times 1. Ang r natin, pila man. So, r, in getting the r or the common ratio is divide the second term over the first term. So, 12 divided by 3 is equals to 4. Right? 4, ang n natin is 5. Exponent of 5. All over 1 minus 4. Next, S sub 5 is equals to 3 times 1 minus, what is 4 exponent of 5? 4 exponent of 5 is equals to 1024 over 1 minus 4 is equals to negative 3. Next, S sub 5 is equals to 3 times 1 minus 1024 is equals to negative 1023 all over negative 3. S sub 5 is equals to 3 times negative 1023 is equals to negative 3069. Ay, wala na ni parenthesis. Negative 3069 over negative 3. So now let's divide this one to get our S sub 5. Negative 3069 divided by negative 3 mo come up ta og answer na 1,023. Positive na siya. Pero, pwede lang din. So, this will be our answer. And this problem. S of 5 is equals to 1,023. So, now let us try another example. Example number 3. Find the sum of the first 7 terms of a geometric sequence whose first term is 3 and the common ratio is 4. So, let's write first the given. So we have a sub 1 or the first term, which is, first term natin is, so first term natin is 3. Next, the n is equals to, ang atong pangita nga term is 7 terms. 7 ang atong n. Next, common ratio. Given man siya, common ratio nato is 4. Now, let's use again this formula. S sub n is equals to a sub 1 times 1 minus r exponent of n. So, 1 over 1 minus r. S natin, ang ating hinahanap na sum of the first 7 term man siya. So, S. Ang atong S sub n, mahimo na siyang S sub 7. Is equals to, kung unsay term nato nga gipangita, maupo na ang naadiri sa atong S. Sub sa atong S. First term or A sub 1 is equals to 3. Substitute natin ang 3. Then, copy ang 1 minus r natin. Substitute natin ang 4 sa r. So, 4. Then, ang ating 7, n is equals to 7 man. So, substitute here ang 7. May mo siya exponent 7. 1 minus r. Using this one, 4. Let's solve na. So, copy ang 3. Pati ang 1, copy, minus. What is 4 exponent 7? It is equals to 16,000. 4 exponent of 7 is equals to 16,384. So, 1 minus 4 is equals to negative 3. S sub 7 is equals to 3. May 3 times, bawasan lang natin ang 16,384 ng 1. So, it is equals to negative 16,383 over negative 3. S sub 7 is equals to, multiply this one. Multiply 3 times negative 16,383. So, ang answer natin, or it is equals to negative 49,149 over negative 3. So, S sub 7. So, let us divide this one to get our answer. Divide by negative 3. 16,000. Positive 16,383. So, therefore, our S sub 7 is equals to 16,383. So, if you are looking now at your module in activity 1, sa what's more in page 6. So, maulang gihapon ni siya nga example. Pero, naay error sa module. Kaya instead dere na part sa module, dere sa katulo, is ang iyang nagamit is dere nga part ay. Ang nagamit sa module is 7. Nagka-error siya. So, dapat 3 lang dyan siya dara. So, akong ipakita ang module. So, sa module, mao ni siya diri ang error. Oops. Diba? Makita na to, 3 diri ang A sub 1 niya, pero dag 7 siya kalit diri, mao ni nga error ang iyang answer. So, take note of this one. So, kani ang tama. Kani atong naa diri ang tama na to nga answer. Okay, class? So, I hope na nasabtan ninyo kung unsa ang pagkuha ang sum of the terms in a geometric sequence. Okay, let's now proceed to the next topic. So, kanina, you have learned about finding the sum of the terms of a finite geometric series using the formula. Since the sequence is finite, we can easily find the sum. But what if the sequence has no last term? Can you possibly find the sum? Now today, or in this time, I will discuss to you how to find the sum of the terms of infinite geometric sequence. Now we will tackle about the infinite geometric series. So we have here a problem. Find the sum of the terms of the geometric sequence 1, 1/2, 1/4, 1/8, and 1/16. You might be wondering, how can you get the sum of the terms of the geometric sequence because its terms are infinite? By the way, is it even possible na magkuha ta sa sum pag infinite siya? If you want to know the answer to that question, you continue learning next lesson. Consider a 1/2 rectangular figure. Divide the figure into various portions as shown here. The rectangle was divided into various portions such as 1 unit, 1/2 unit, 1/4 unit, 1/8 unit, 1/16 unit, and so on. The rectangle can still be divided into smaller rectangles up to infinity. So, pwede pa ni natong i-divide. I-cut pa nato into half ang ating rectangle. If the areas of all rectangles are added, this will give a sum of 2 square units. This scenario indicates that you can still find the sum of the terms of an infinite geometric sequence. In mathematical statement, we can write the sum of the areas of the rectangles as follows. So, pwede nato ni siyang i-add into 1 plus 1/2 plus 1/4 plus 1/8 plus 1/16 plus 1/32 and so on is equals to 2. So, kaning 2 nato diri mao ni siya ang ginatawag natong sum of the term of an infinite geometric sequence. And this ellipse here, or ellipsis, kani siya. This is what we call ellipsis, is a set of 3 dots that indicate infinity. Based from this example, we can have the formula, which is s to the infinity sub infinity is equals to a sub 1 over 1 minus r, where s sub infinity is equals to sum of infinity. Then a sub 1 is our first term, still our first term. Then r, common ratio. So that's it. Kani ang atong dapat tandaan pag mag-solve ta og sum of the infinite geometric series. So let us test if the formula is correct. So let's try to solve this problem again using the formula. We have s to the infinite. I mean s infinite is equals to atong a sub 1 is kani. First term is 1 over 1 minus ang r natin is r is equals to a sub 1 a sub 2 over a sub 1. So atong a sub 2 is 1 half. 1 half over a sub 1 natin is 1. 1 half divided by 1 is equals to 1 half. So, mao ni siya ang atong r. Substitute nato ni r nato diri a. So, 1 minus 1 half. Now, let us solve. Pero matag substitute. S sub infinity 1 over 1 minus 1 half is equals to 1 half. Then, next, proceed ka here. S sub infinity is equals to 1 divided by 1 half is equals to 2. Now, same lang ba siya? Ganiha. Ang answer na to. Same lang siya, ani. Diba? We tested the formula. Using this formula, we can also get the same answer kung mugamit ta ani and also kani. So, same silang duhag answer. Take note, this formula is applicable only to infinite geometric series when the common ratio is lesser than 1 but greater than negative 1. So, timan iha, common ratio niya is lesser than 1 but greater than negative 1. Mao lang na siya ang inyong dapat tandaan. So, let's proceed to our next example para mas sabtan pa ninyo ang atong lesson. Now, let's have our second example. Find the sum of the terms of the infinite geometric sequence 3, 1, 1/3, and so on. So, let's solve this one. Let's write first the given. A sub 1 is equals to 3. R is equals to, hanapin muna natin ang common ratio. So, R is equals to second term over first term. So, 1 over 3. So, now, let's write the formula. S sub infinite is equals to A sub 1 over 1 minus R. Next, nating gagawin is substitute the given here in our formula. So, S sub infinite is equals to, atong A sub 1 is kani 3. Then, 1 over 1 minus ang R natin is this one, 1 over 3. Now, let's solve S to the S sub infinity is equals to 3 over 1 minus 1/3 is equals to 2/3. And next, divide this one to get the answer. S sub infinity is equals to 9 over 9 over 2. No, mauna ni siya ang atong answer. Ma'am, nga yung 9 over 2 wala siya. So, let's change this one for us to get 9 over 2. Ang kanay fraction, divide man na to siya, no? Ang naasa denominator is a fraction. So, let's make this one. Instead na division, himuon na to siya multiplication. So, 3 times may man siya 3 over 1 times 3 over 2 is equals to 3 times 3, 9 over 1 times 2, 2. Mao na siya 9 over 2. Nasabtan na nga nung 9 over 2. Kung giunsa na ako pag-solve. So, pag makakuan kayo mo nga fraction ang inyong denominator, i-change ninyo ang i-change ninyo siya into multiplication. Kaya division man ni siya, i-change ninyo into multiplication. Then, pag ang kanipong denominator ang inyong fraction, dari sa ubos, kani siya, di ba mauni siya ang denominator. Kani. Ang buhaton ani ninyo nga denominator para ma-change nato ning division into multiplication is atong iswap ang kaning denominator na 3, himuon nato siyang numerator like this one. So, ang 3 na numerator, i-over na nato si 2. Kaning numerator din mahimo na siyang denominator. Then next, ang kaning ato ang 3 na whole number diri sa numerator, pwede nato siyang butangan og denominator na 1. Pwede po maging imaginary lang ng 1. Or pwede po whole number lang siya ba nga 3, ingana lang. Pero for you to make it easier nga ma-visualize ninyo, so pwede na ninyo butangan og 1. Then, multiply numerator by numerator, so equals 9. Then, multiply denominator by denominator equals 2. Therefore, our answer will be 9 over 2. Yan na lang siya ka-easy mag-multiply sa fraction. So, let's proceed now to our next example for you to further understand the how to find the sum of the infinite geometric series. Now, let us proceed to our third and last example. So the question is, find the sum of an infinite geometric sequence whose first term is 5 and common ratio is 1/4. Let's try to solve this. First, let us write the given. A sub 1 is equals to 5. Okay, kani first term is 5. R natin, common ratio is equals to 1/4. Naana sa question ang given. So now, let's substitute these values sa ato ang formula. So, what is our formula? In infinite geometric series, we have S sub infinity is equals to A sub 1 over 1 minus R. Dali na ma-memorize the formula. Now, substitute the given. So, S sub infinity is equals to A sub 1 nato is kaning 5. So, 5 over 1 minus, ang R nato is 1/4 minus 1/4. S sub infinity is equals to 5. 1 minus 1/4 is equals to 3/4. Ang isa ka buong, isa ka kilo, bawasan o 1/4. So, 3/4 yun, diba? So, next, S to the infinity is, S sub infinity is equals to, pila man, diba? Ang solve na to, ani, katong discuss na ko, gani ha? Kapag fraction ng atong denominator, i-change nato ng division into multiplication. So, So, may mo siyang 5. At lang over ang 1. 5 over 1 times 4. Ang denominator ani mo himuong numerator. So 4. Ang kaning numerator maging denominator. So 3 is equals to, next is multiply the numerator by numerator and denominator by denominator. So 5 times 4 is equals to 20 over 1 times 3 is 3. Now, our answer here is this one. May mo siyang 20 over 3. Okay. So, that's it. Ngayon, anaon lang pag-solve ang pagkuha sa sum of an infinite geometric sequence sa atong topic karon. So, I hope nga masabtan ninyo kung giunsa nato siya pag-solve o ma-remember ninyo always ang formula in finding the sum of the infinite geometric sequence ug ang katong isa ganiha first natong gi-topic which is the finite geometric series or the sum of the finite geometric sequence. That's it for today and thank you class.